In this video, I would like to give you a quick tutorial on how we can code one of our kinematics problems that we were solving in the notes. So if I go over here and flip to our chapter 2 notes, we had example 5, where we have a car traveling along a straight line in a stretch of highway. 15 meters per second is its initial speed, and it accelerates with an acceleration of 2 meters per second squared. And we were asked to find the velocity at 5 and how far it went in 5 seconds. So what I want to do is animate this, and we're going to just represent the car as a box. So we'll go into Glowscript. I've loaded up glowscript.org, and we're going to I'm going to sign in here and go into my chapter 2. I'm just going to create a new program. I'm just going to call it chapter 2 example 5 and create. Okay, so first thing we want to do is we would like to make an object. So we're going to call the car box. And of course we've got to give the car a position. So we're going to go pos equals vec. So remember, position is a vector, and we're going to put it at the origin. So it's at 0x for and y and z. And the next thing we're going to do is we're going to give it a size. So size is also a vector quantity. We're going to make it 5 long, 2 wide, and 2 high. And we can give it a color, and we'll say color equals color.blue. And let's just take a look and see what that looks like. So if we can run the program in here, we can see that we have a box. And unfortunately, it takes up the whole screen. So if I zoom out here, zoom in, maybe hold the control key around here, you can see that there's my box. But I want to put it on an axis so it doesn't fill up the whole screen. So let's now add an axis on here. So axis equals, and in this case, we're going to be using an arrow. So just by the way, to remind you, when I'm looking up for objects, I simply just go to Google in here and I type in, I don't know what the proper syntax is for an arrow. So I just Google Glowscript and then arrow, and then usually the first hit will basically have some documentation about an arrow. So you can see as an arrow, we can define a pointer as the object, the name, and then over here is the shape, the arrow, and we have a position. We also have a shaft width, which is shown in here, and then we have axes. So this is the old vPython language. By the way, they now don't use axes and length, it's just axes. So I'm just going to copy and paste this syntax into my Glowscript here, and here we go. And maybe I'll just keep it all in one line, and move that over here. Change this axes so it's just axes in length, and it's just rather axes. And we're going to put it at the origin, 0, 0, 0. And of course, we're going to have the axes now stretch a fair distance. Let's say just perhaps 150 units, and then 0, 0, that's fine with me. So this is basically stretching along the x-axis and nothing along vertically or in or out of the screen. So if I run it now, you can see that I have an error. And that's good that you can see how I'm going to debug here. So we can take a look and see that I have an error somewhere in my definition, and I can see, oh, I've got 2 equal signs. That doesn't make sense. So let's run that program again. And there you go. And there's my, now if you look carefully in my box, whoops, I zoomed in, it's the box is sitting on the axis. So ideally it would be good if we can just make it be above the axis. So let's move that position so it's a little bit above. Put the y-axis like, I don't know, say 3 units, and just take a look and see what that looks like. Now the box is on top of the axis, more or less. So now what we need to do is, going back to our problem, is that the box is placed at the origin. It's already moving at a speed of 15 meters per second. So going back to my Glowscript here, I'm going to define the velocity of the car. We're going to call that v0. And that's equal to 15. So we're now giving the variable a scalar amount of 15. What else do we have given in the problem? We also have that the car is accelerating at 2 meters per second squared. So let's also define that. A is equal to 2. And feel free to, add in comments. If you add a hash here and write defining the initial speed, that helps kind of when you look back at your code to see what you're actually doing. This is defining the acceleration. All right, now, of course, we're going to start at a time of 0. So we need to define that time variable, set that. That's, again, defining the initial time and the time variable as well. And dt is my increment of time. So we'll just go, I don't know, 0.1. Maybe we want to change that. This is defining the increment of time. So we're going to increment time in our loop. So now we want to make the car move and accelerate to the right. So we want to accelerate to the right until we reach a time of 5 seconds. So the normal, easiest way I find to do things and have it keep changing is to use a while loop. So we use while, that's the condition here. We're going to do while t is less than 5, and we follow that with a colon. All right, so this is going to continue doing this operation until t gets to the value of just under 5. Once it gets to 5, then it's going to exit out of the loop. Because right now t is 0, if you can see. So what we need to do now is update the position of the car. So you may want to, maybe if we're going to think of this in terms of a physics equation, we may want to change that and add in an x0. x0 is essentially 0. It's the initial position. You could also say x0 is the car's position in the x-axis initially. Okay, so now back to this loop over here. We want to basically keep making the car move over to the right. So we're going to do update the car's position. So car is the object, pos, we're changing the position, equals the original position, you can call it x0, plus v0 times, and v0 was defined up here as 15, times t plus 0.5 times a times t, which is basically t squared. So what I'm using, if you recall back in your kinematics equations, we're using this equation right here. And we're just going to write it. I know there's other ways of doing it. We can use a calculus approach, but I'm going to try to keep it as real and close to the physics problems that we've been doing. So we're defining, we're going to keep updating the position. We're going to try to plot, or actually eventually plot a graph, and show this kind of as it moves and accelerates. So that's updating the position. So this is x initial, this is x original, which is the original position of the car. This is the initial velocity of the car in the x direction, which is 15, times the time, plus a half times the acceleration times time squared. Now, by the way, just a note, you cannot use, for example, t to the power of 2. That does not work. It basically, it must be t times t, or you could do t star star 2. That's another way of doing it. Just a kind of quick note, because that sometimes confuses people. All right, so next thing is we have to increment time, right? Because otherwise you're not going to, just going to stay in the loop. So we're going to take that time, and we're going to add whatever the increment of time we have. So this is the original time, and we're going to add dt to it each time. Okay, so press run, and boom, ooh, error. What's that mean? So line 12 says the property pos must be a vector. So that's good that you're seeing that. See, right now, I can see that I've actually defined car.pos. Ooh, see, car.pos is defined as a vector quantity. So it's good that you're seeing my mistakes, actually. You're adding a number times a number plus another number times a number squared, and then you're making it equal to a vector. And a vector is something that has both x, y, and z. So how are we going to fix that? Because really we're only updating the horizontal position. So we're going to add a dot in here and x. That way you're only looking at the car's position along the x-axis, which is really just 0 initially. You're only updating this, which is now just a number. So if I run the program now, hopefully it'll work. Aha! But you may notice I made one more thing. It went so fast that you didn't see it. So we kind of have to slow the program down. So what we need to also add in here is a command called rate. And the one I typically like to use is rate 60. And so that will basically slow the calculation of this. Okay? So if I run it, I'm going to see that, yeah, now it's going to do that. Now you could add some other features. You can add like a trail to the object. Let me look that up for a moment. All right, I'm going to just go into Google and simply type in Glowscript and trail, yes. And hopefully the first hit, oh, yep, it's leaving a trail. And so in that help page, you can see some specifics about how to make a trail. You can also attach an arrow, but we're going to basically make a trail. And we're going to change the type what you add, because you can either, if you just leave it as make trail, it's just going to connect them all and you'll get this kind of nice curve on it. But I like to see the dots to see if they're spacing out properly. So we're going to do make trail, and then we're going to add in the trail type is going to be points. You could also change the interval at which it does it, so it does it every 10th sphere and so forth. But let's just go with this and see what we get. So I'll put comma and enter, and let's run the program now with this make trail added. So if I run it, all right, you can see the object moving. But if you zoom in here, you can start to see that these dots are starting to basically get further and further spread apart. It's a little bit hard to kind of see it when it was firstly set up, but if you zoom in, you can hopefully see it. Now, I actually changed my velocity to 0 so you could see that, but it's initially at 15. So if I run this now, maybe you'll see it moving all the way out that distance, and the spacing of the dots may not be as clear, that they're getting actually bigger. So one more little feature that we can do after the loop is maybe we want to print a statement. So print is a way of adding text output. So let's say if we want to go back to this question over here, we were trying to figure out what the velocity of the car was. So I'm just going to add in the velocity of the car after 5 seconds. All right, so I'm going to add that in here in quotes. So the velocity of the car after 5 seconds is, quote, and then put a comma in here. Now, by the way, I'm using the print command. If you go to Google again, just Glowscript, print, that'll show you basically a text output. And in here, you can kind of see a little bit about the syntax. So if you put it in quotation marks, you can put in what you're looking for. But if you add a comma and then a variable, then you can add in whatever other thing that you want to print out. So if over here I want to print out let's say the position of the car after 5 seconds, I can simply say, well, that was actually the car's position here. So I can put this variable right in here, car.pos, comma, let's maybe open up the quotes and put in meters. All right, and let's see if we get a little statement at the end. So we're going to run it here, and boom, at the bottom it says the position of the car after 5 seconds is 100 meters. So now it's outputting the actual position of the car. If we go back to our problem, we also had to talk about what the velocity was. So the thing is that I did not calculate the velocity every time. So do you remember how you can calculate the velocity? Do you remember how we solved this problem? How do we calculate the velocity? Well, what kinematics equation did we use? I think we used this one, v equals v0 plus at. So you just need to add another line to this code, somewhere in here, where we're going to be updating the velocity. So the velocity, v, now v we haven't defined, so we have to put up here like initial velocity, like v equals v0. So this is defining the velocity of the car. And we're going to set the initial velocity to be whatever it was initially, which was 15. If I did not put that in there, it wouldn't recognize it because I'd be using some variable that I haven't defined before. So remember, when you define all your variables, that you do it before you commence your loop. So v equals v0, remember that equation, plus a times t. And so we're just updating the velocity each time. And let's add in another similar statement over here. And we want to print the velocity of the car. So the velocity of the car after 5 seconds is now going to be simply what the variable v that we just added in. And it's going to be in not meters, but meters per second. So let's see if that works out properly. So we run the program, and there we get the velocity and the position of the car. So that's what you're expected to be able to do. All right. The next little bit we'll add in, but I think the video is getting a little long, is to show how you would graphically do this. And that's it.